This is video 20.5. We will be looking at a simple RC circuit. The question. An RC circuit is shown in the diagram below. It consists of a resistor, a capacitor, a battery, and a switch. Now if we assume that the circuit starts open without any charge on the capacitor, we'd like to know, if we close the switch, how long does it take until we have 6 volts across the capacitor? And if we wait until the capacitor is fully charged and then we open the switch, how long does it take for half of the charge to decay? Step 1 will be to find the time constant. It's a measure of how long it takes for the capacitor to charge or discharge. It's usually labeled by tau and is the product of the resistance and the capacitance. In this case, it's 150 microseconds. Now we'll find the time it takes for the potential difference across the capacitor to reach 6 volts. This is the expression that gives the voltage across the capacitor as a function of time. V0 is the potential difference that will be reached after an infinite amount of time, which is the potential difference of the battery, in this case 12 volts. And tau is the time constant. So we want to set V sub c equal to 6 volts and then plug in what we know and solve for t, the time it takes. If we do this, we have the following expression. Dividing both sides by 12, we have this expression. Rearranging a bit more, we can work it into this form. Now when you have an expression like this, where the quantity you would like to know is in the exponent, you have to use a logarithm. In this case, because it's e raised to some number, we'll use the natural logarithm. Taking the natural logarithm of both sides, simplifies the left-hand side, because it just gives us the exponent, negative t over 150, which is equal to the natural log of 1/2. Solving for t, we find the time it takes is 104 microseconds. Now we'll find the time for half of the charge across the capacitor to decay. We assume that it starts fully charged and then we open the switch. This expression gives us the charge on the capacitor as a function of time after a switch has been opened. Dividing both sides by Q0, which is the steady state charge, we have this expression. Now we don't know what Q0 is, although we could find it easily because it's equal to CV. All we're interested in knowing is when this ratio is 1/2. When the charge on the capacitor is 1/2 of the charge it had when it was fully charged. So this is our relationship that we're looking to solve. However, on the previous slide, we ended up with this exact same mathematical relation when we were looking to find the time it takes for half of the voltage to be reached. So we already know the answer. The time is 104 microseconds. And that concludes video 20.5. Check out PhysicsX on the app stores. This revolutionary physics app for smartphones and tablets contains over 100 videos and 500 multiple choice questions designed by education experts. It's been proven to improve scores for intro college physics, AP Physics, MCAT Physics, and more. Just look for the blue icon.